Quadratic equation, natures of roots. In previous lessons, we have discussed the relationship between the roots and the coefficients, and we learned that the relationship are given by the sum of roots and the products of roots. And in these videos, we are going to discuss the natures of roots of quadratic equations, and the natures of roots of quadratic equation is determined by the discriminant b squared minus 4ac. Okay. In solving quadratic equations, we learned that we can solve any quadratic equations by using the quadratic formula. And this is the quadratic formula, x equal to negative b plus minus square root of b squared minus 4ac, and then over 4a. Now, we should take notes that in this formula, we have a plus minus sign here, which means that we are going to have two roots. When we plus a number, we get one root, and minus the numbers, then we get another root. Okay, and there's also the square root inside this formula, which means that the root can be real or unreal. Now, unreal numbers, or normally is called the imaginary numbers, are the numbers with the square root of a negative number. For example, square root of negative 3, so this is unreal or imaginary number. Square root of negative 12, this is also imaginary number, or a square root of negative 200. Okay, square root of any negative numbers are unreal numbers or imaginary numbers. In a nutshell, the positive negative here indicates that we're going to have two roots, and the square root here indicates that we are going to have a real root or unreal root. Okay, now let's try to explore this to see what it really means. Now, to make it simple, let's assume that this negative b is equal to 1, and this 4a is also equal to 1, and therefore our x is equal to 1 plus minus square root of b squared minus 4ac. Now, let's say our b squared minus 4ac is greater than 0. For example, 4. Okay, if it's greater than 0, so if b squared minus 4ac is greater than 0, so what will be our roots? So x is equal to 1 plus minus, okay, let's say our b squared minus 4ac is equal to 4. Okay, 4 is greater than 0. Okay, so we know that the square root of 4 is equal to 2. So therefore this will become 1 plus minus 2. 1 plus 2 is equal to 3, and 1 minus 2 equal to negative 1. So the roots is 3 or negative 1. So we have two roots, and both of these roots are real. So we have two real distinct roots. If our b squared minus 4ac is greater than 0. Now you can try it with any positive numbers. You will still get two real and distinct roots. Okay, because 1 plus numbers we get a root, and 1 minus another numbers we get another root. So we have two distinct roots. Okay, now how about b squared minus 4ac equal to 0? Okay, if b squared minus 4ac is equal to 0, so our x is equal to 1 plus minus square root of 0. Okay, 1 plus 0, we have 1, and 1 minus 0, we also have 1. Okay, so we still have two roots, but the two roots are the same. So we say we have two equal roots. Okay, two real equal roots. Okay, so when b squared minus 4ac, then we have two real equal roots. How about b squared minus 4ac less than 0? So x is equal to 1 plus minus, let's give any negative number. Let's say this will be negative 3. Okay, now when we have square root of negative 3, then it become unreal. This is an unreal number or imaginary number, and we have two distinct roots, because 1 plus square root of negative 3, we have one root. 1 minus square root of negative 3, we have another root. Okay, let's write it this way. So 1 plus root 3, this is one root, and 1 minus root 3. Sorry, it's negative root 3. Negative root 3. 1 minus negative root 3, so we have another root. And both of these are unreal because we have the square root of negative numbers. Okay? So, from here we can see that the types or the natures of roots is determined by this b squared minus 4ac. If b squared minus 4ac is greater than 0, then we are going to have two real and distinct roots. And if b squared minus 4ac is equal to 0, then we are going to have two real but equal roots. And b squared minus 4ac less than 0, we are going to have two distinct but unreal roots. Okay. So the discriminant. The expressions b squared minus 4ac in the general formula is called the discriminant of the equation, as it determines the types of roots that the equation has. And when b squared minus 4ac equal to 0, we are going to have two real and equal roots. B squared minus 4ac greater than 0, we are going to have two real but distinct roots. When b squared minus 4ac less than 0, we are going to have two unreal and distinct roots. Okay. Now let's see this example. Determine the natures of the roots of the following equations. 4x squared minus 3x plus 5 equals 0. Now to determine the natures of the roots, we need to know the coefficients a, b, and c. Yeah? So for question number 1, our a is equal to 4, and our b equal to negative 3, yeah? And c equal to 5. Okay, so and then we have this b squared minus 4ac. This is the discriminant, and b is negative 3, so negative 3 squared minus 4a is equal to 4, and c equal to 5. 5. So this is 9 minus 4 times 5 is 20. 20 times 4, 80. 80. So 9 minus 80 equal to negative 71. Negative 71. And this is less than 0. This is negative. And therefore, this quadratic equations has two unreal and distinct roots. Okay. Now for b, a equal to 3, b equal to 8, and c equal to negative 3. So therefore, b squared minus 4ac equal to b equal to 8, so 8 squared minus 4a equal to 3, and c equal to negative 3. Okay, so this is 84 and 36. 36. Okay, and this is equal to 120, and this is greater than 0. So when it's greater than 0, we are going to have two real and distinct roots. Okay. Now for c, a equal to 3, b equal to 6, and c equal to 3. So b squared minus 4ac, b equal to 6, 6 squared minus 4, a equal to 3, and c is also equal to 3, and so this is equal to 36 minus 36 equal to 0. When b squared minus 4ac equal to 0, we are going to have two equal roots. We're going to have two equal roots. Okay, and the roots are real. The roots are real because we don't have square root of negative numbers, or we can say two real equal roots. Two real equal roots. So this is how we determine the natures of roots of a quadratic equation. Now let's see these examples. We have a quadratic equations here, and then we are told that this equation has two equal roots. So we are asked to find the possible values of t. If the quadratic equation has two equal roots, means that the discriminant b squared minus 4ac is equal to 0. And in order to find the coefficients a, b, and c, we need to rewrite these equations into its general form. So let's copy these questions first. T plus 3 x squared plus 2t equal to 12x. Therefore, t plus 3x squared. Now, in general form, the right-hand side must be equal to 0. So we move this 12x to the left. It becomes minus 12x. And then plus 2t equal to 0. So now this equations is in general form, and therefore we can find the values of a, b, and c. A equal to t plus 3, and b equal to negative 12. B equal to negative 12, and our c equal to 2t. C equal to 2t. Okay. So after we have this the values of a, b, and c, then we can plug in this value into the discriminant b squared minus 4ac. So let's rewrite this here. So we know that because it has two equal roots, and therefore b squared minus 4ac is equal to 0, and b equal to negative 12 square minus 4a equal to t plus 3, t plus 3, and c equal to 2t, and this is equal to 0. The square of negative 12 is 144. Negative 4 multiplied by 2t, we have negative 8t. Okay, and then this multiplied by t plus 3 equal to 0. So 144, 8t multiplied by t, we have 8t square, and negative 8t multiplied by 3, we have minus 24t equal to 0. Now, the numbers look a little bit big for a quadratic equations if we would like to factorize it. So let's see whether we can reduce it to smaller numbers or not. Now, you should realize that all the coefficients are the multiples of 8. So we can divide this whole equations by 8. So we divide this by 8, and 144 divided by 8 is equal to 18. This is 18, and 8 divided by 8 is equal to 1, so this becomes minus t squared, and 24 divided by 8 equal to 3, 3t equal to 0. And let's rearrange this so that it's in general form. Now we have negative t squared here. Preferably we change this to positive t squared. That's easier for us to factorize it. So what can we do is we multiply these whole equations by -1. So this will become t square, and this become positive 3t, and this become minus 18 equal to 0. Now you can see that we obtains another quadratic equations, okay? And we can solve these equations by using a few methods, factorizations, completing the square, and quadratic formula. Now in this case, I'll try factorization first, okay? So t square, to obtain t square, so we have t multiplied by t, so we have t square, and to get -18s, the factors of 18 are 3 and 6, let's say, okay, 6 and 3, yeah. Let's try this one first, and we have -18, which means one of it must be in negative. Okay, so 3t is positive, so let's try positive 6 first. Okay, this is positive 6 and this is -3, and then we have cross multiplications. Okay, t multiplied by positive 6, so we have positive 6t, and t multiplied by -3, we have -3t, and the sum is equal to positive 3t, and this one, the product is -18, and yes, this is exactly what we want. We have t square, and then we have -18, and we have positive 3t, and therefore these are the factors. So t plus 6, t minus 3 equal to 0, and therefore t is equal to -6 or t equal to 3, and these are the possible values of t, because we are asked to find the possible values of t. So t can be -6 or 3. If we would like to make these equations has two real equal roots. Now let's see this example. We have a quadratic equation, and then inside this equation we have a constant p, and then this equation has two real distinct roots, which means the discriminant b squared minus 4ac must be greater than 0. And then we are asked to find the range of values of p. Okay, now this equation is already in general form, so we can straight away tell the values of the coefficients. A equal to 1 minus 2p, and then b equal to 8p, and our c equal to -2 plus 8p. Okay, and let's plug in this ABC into this inequality. B is equal to 8p, so 8p squared minus 4. A is equal to 1 minus 2p, and C is equal to this. Okay, let's change this to the square brackets. So -2 plus 8p. Okay, so this is equal to 64p squared minus 4. Let's try to solve this part first. 1 multiplied by -2, so we have -2, and 1 multiplied by -8p, so we have -8p. -2p multiplied by -2, this is equal to positive 4p, and -2p multiplied by 8p, so this is equal to, sorry, this is -8p, so it become positive 16p squared. Okay, so, and this is greater than 0, 64p squared And then let's rearrange this part. So it become -2, -8p plus 4p become -4p, and then it's a plus 16p squared greater than 0. And let's expand this. -4 multiplied by -2 plus 8p, -4 multiplied by -4 plus 16p. Okay. Now we don't have a p here. No, -4 multiplied by -2, we have +8 without p here. Okay, and then -4 multiplied by +16p squared. This become -64p squared greater than 0. Okay, now we have 64p squared, and we have -64p squared. So this becomes 0. So the equations become 16p plus 8 greater than 0, and therefore 16p is greater than -8, p is greater than -8 over 16, and therefore p is greater than -1 over 2. So this is the range of values of p. Now let's see another examples. In these questions, we are told that this quadratic equation has no real root, which means the discriminant b squared minus 4ac is less than 0, right? Okay, so for these equations, this is already in general form, so therefore we can straight away tell us what's the coefficients a. So our coefficients a is the coefficients for x squared is 1, right? Okay, and this is coefficients b. So our b is equal to -2p, and this is our c. So c equal to p squared plus 5p minus 6. Okay. So let's plug in this ABC into the discriminant. So b squared, b is -2p, so it becomes -2p squared, and then it's minus 4. Our a is equal to 1, a equal to 1, and c is a little bit long, so it's equal to p squared plus 5p minus 6. Okay, and this is less than 0 because there's no real roots. So -2p squared equal to 4p squared. Okay, and -4 multiplied by p squared, we have minus 4p squared, and -4 multiplied by positive 5p, so we have -20p, and -4 multiplied by -6, we have positive 24. And this is less than 0. 4p squared minus 4p squared is equal to 0, so we have -20p plus 24 less than 0. Let's move this positive 24 to the right hand side. It becomes -24. -20p less than -24, and let's eliminate the negative. So we multiply the equations by -1. Now remember, for inequalities, if you multiply the inequalities by -1, the less than signs will change to more than. So this becomes 20p, and it becomes more than 24. More than 24. So when you multiply inequalities with the negative numbers, this symbol will change. So our p is greater than 24 over 20, and simplify these fractions. Our p is greater than 6 over 5. So this is a range of p, because in the questions they would like us to find the range of values of p. P is greater than 6 over 5. This is the answer.